Hi viewers, welcome to my channel. This is Sridhar Reddy Yelpeddi, Assistant Professor of Physics from Government Degree College for Women, Nalgonda. Welcome to my channel Sri Quantum Academy. Feel the physics at glance. Today I am going to discuss with you topic how the zener diode helps to regulate the voltage. How the zener diode used as a voltage regulator. Generally, regulation of the voltage, that means there are no fluctuations, there are no changes in the voltage. To keep that voltage as a fixed constant value, generally we use the zener diode. This video helps you to understand how the zener diode helps to stabilize the voltage. జనరల్గా మన ఇంట్లో ప్రతిరోజు ఈ వోల్టేజ్ స్టెబిలైజేషన్, వోల్టేజ్ రెగ్యులేషన్ అనే దాని గురించి మనం డైలీ మన ఇళ్ళల్లో చూస్తూ ఉంటాం. టీవీ, ఫ్రిడ్జ్ అలాంటివి ఒక స్టెబిలైజర్ అనేది ఉంటుంది. ఎందుకు అనంటే టీవీ అనేది 12 volts ఆర్ 15 voltsతోని వర్క్ చేస్తుంది. అంటే ఒక టీవీ రన్ అవ్వాలి అంటే మనకు 15 volts పవర్ కావాలి. కానీ ఒక్కొక్కసారి మన ఇంట్లోకి వచ్చేటువంటి పవర్లో ఫ్లక్చుయేషన్స్ ఉంటాయి. దట్ మీన్స్ sometimes power value increases, sometimes decreases. So that up and downs is called fluctuations. In that case, if the power is fluctuating, that means let us suppose the power which is coming into our home is greater than the desired value. If that is directly connected to the TV, what happens? Actually TV works with only 15 volts voltage, right? If it is greater than that value, then what happens? That means you are giving more power to the TV. Obviously what happens? The parts inside the TV may destroy, right? This what you experience. మనం చెప్తూ ఉంటాం కదా, టీవీ ఎక్కువ కరెంటు వల్ల టీవీ కాలిపోయింది అంటాం. కరెంట్ ఎక్కువ వచ్చింది, టీవీ కాలిపోయింది అని చెప్తాం. ఎందుకైంది అంటే టీవీ వర్క్ చేయడానికి ఒక ప్రాపర్ కాన్స్టాంట్ వాల్యూ ఉండాలి. బట్ అలా కాకుండా ఒకసారి తగ్గడమో పెరగడమో ఈ ఫ్లక్చుయేషన్స్ ఉన్నప్పుడు మనకు ఆ డివైస్, ఇప్పుడు ఆ టీవీ అనేది సరిగ్గా పనిచేయదు. అప్పుడు మనం ఏం చేయాలి అంటే ఈ ఫ్లక్చుయేషన్స్ లేకుండా ఒక కాన్స్టాంట్ వాల్యూ, దానికి ఎంత కావాలో అంత. సో యూ హ్యావ్ టు సప్లై ఎ డిజైర్డ్ కాన్స్టాంట్ వాల్యూ ఆఫ్ ద వోల్టేజ్. సో ఇన్పుట్లో వచ్చే ఈ చేంజెస్ వెనక ముందు తగ్గుతూ ఉన్నా సరే మనకు అలాంటి చేంజెస్ ఏం లేకుండా ఒక కాన్స్టాంట్ వాల్యూ ఇవ్వడానికి మనకు ఒక డివైస్ ఉంది. ఆ డివైస్ని వోల్టేజ్ స్టెబిలైజర్ అంటాం. A zener diode helps to stabilize the voltage. Zener diode can be used as a voltage regulator. ఇది ఎలా వోల్టేజ్ రెగ్యులేటర్గా పనిచేస్తుంది అనేది ఇన్ దిస్ వీడియో ఐ విల్ ఎక్స్ప్లెయిన్ టు యూ. బిఫోర్ గోయింగ్ టు వాచ్ మై వీడియో, ప్లీజ్ సబ్స్క్రైబ్ మై ఛానల్ ఇఫ్ యూ నాట్ డన్. ప్రెస్ బెల్ ఐకాన్ టు గెట్ లేటెస్ట్ అప్డేట్స్. ఫస్ట్, వాట్ ఈజ్ వోల్టేజ్ రెగ్యులేటర్? Definition for regulator is, it is the device which supplies a constant voltage in output. That is called voltage regulator. That means it is the device which supplies a constant voltage in the output. Generally, a voltage regulated power supply provides a constant output voltage irrespective of the input voltage fluctuations or load fluctuations. Whatever the changes are happening, irrespective of the changes, it always provides you a constant desired value. That device is called regulator. Generally, a zener diode is used to stabilize the voltage. This zener diode helps to stabilize the voltage which is supplying to the load. Here load means TV. You can say load is nothing but TV. That means the device which is using this power. So load means the device which is utilizing this voltage to work. Now TV is using this power. That's why generally TV is a load, fan is a load, fridge is a load. That means the device which is utilizing the power is called load. Now you have to supply constant voltage to that load. That means you have to supply constant voltage to the TV or to the fridge, like that. So before supplying the voltage to the TV, you have to use a stabilizer. That's why generally first you connect stabilizer to the mains. From the stabilizer connect to the fridge or TV. That means TV power is not directly coming from the mains. First mains power is coming to the stabilizer. Now this stabilizer keeping constant voltage, now that voltage is supplied to the TV. So you are supplying a constant output to the load with the help of stabilizer, that means with the help of zener diode. Generally, in voltage regulating circuit of a zener diode, it is always connected in reverse bias. That means to stabilize the voltage, zener diode should be operated in a reverse bias condition. And in that circuit, a resistance R is also included. Why this resistance is included? This resistance limits the current which is flowing through the diode. That means this resistance stops the heavy flow of current to the diode. Sometimes if it crosses the maximum desired value, what happens? The device will destroy completely. So to limit the current which is passing through the device, you have to use a resistance. Now load which is utilizing this power is indicated with load resistance. Now this load resistance RL is connected in parallel to the zener diode. So first, zener diode should be operated in reverse bias. Next, in that circuit you have to use a resistance. Why this resistance? This resistance limits the maximum current that can flow through the diode. To protect the diode, generally you use a resistance R. Load resistance RL is connected parallel to the zener diode. So if you see the connections in circuit, see here, this is a zener diode. Now P side is connected to the negative terminal and N side is connected to the positive terminal. That means this device is in reverse bias now. Okay, so zener diode is connected in reverse bias. This zener diode breakdown voltage is Vz. That means the voltage at which this device reaches to the zener breakdown is called zener voltage. That zener voltage is Vz. This is the input voltage which I am supplying. So this is V input voltage. Now in this circuit what I am doing? I am applying a resistance R in series. Now this is the resistance R which is connected in series. Now load resistance RL is connected parallel to the diode. That means two ends of the diode parallelly connected to the two ends of the load resistance. Now this load resistance RL is indicated with arrow mark. This arrow indicates the changes. That means it is not a fixed value. So load is changing. That's why I am indicating with a arrow mark on the resistance. Now the output voltage is nothing but here load resistance is the output. So here on the output, this device should provide a constant value. Then only I can say it is stabilized. Now let us suppose current coming from the battery, that means from the mains, is IZ into the circuit through the resistance R. Okay. Now at this junction, this current is dividing into two parts. Some of the current is flowing through the resistance IL and remaining current is passing through the diode, that is IZ. So this total current I is divided into two parts, IL and IZ. Now how it works? Working principle. So this battery is connected in reverse bias to the diode. So when you increase the reverse voltage, when the voltage is greater than the zener breakdown, the reverse saturation current increases to large value and voltage drop across the diode remains constant. That means once the diode reaches to the zener breakdown, then after that any changes in input voltage or output load that is not affected this voltage drop across the diode. That means across the diode that voltage Vz is fixed value. Okay. Now I is the current drawn from the battery source. Now IL is the current across the load. IZ is current through the zener diode. Now total current I is equal to IZ plus IL. Right. Now similarly input voltage is VIN. Right. V input. Okay. V output voltage is nothing but the voltage across the load also. Right. So load voltage or output voltage. So VL or VO or V out, whatever you can write. Now V output is equal to, actually load resistance is RL, load current is IL. Now V is equal to IR formula is there na. So now V load is equal to V out is equal to IL into RL, load current into load resistance. So V out is equal to IL into RL. Right. This is output voltage. right? So actually there is a resistor R. Now current passing through the resistance is I. So now voltage drop across the resistor is VR is equal to current into resistance, that means I into R. So total input voltage V in is equal to sum of the voltage is dropping across the resistor and remaining is across the output. So V in is equal to VR plus V out, right? So V in is equal to VR means IR plus V out. Okay, actually V out is equal to, bring this IR this side, V out is equal to V in minus IR. Now this output voltage VO is always constant. Even Vi may changes or output load may changes. Whatever the changes happens, but V out is always constant value, and that is equal to the zener voltage, that means Vz. So Vz is equal to V out. Since diode is connected in parallel to the load, so whatever the voltage is there on diode, that is equal to the voltage on the load. So Vz is equal to V out, right? Now question is, why the variation occurs in output voltage? So there are two reasons by which variation can occur. Number one is, sometimes input voltage changes, that means there are the fluctuations in input. అంటే మన ఇంట్లోకి వచ్చేటువంటి కరెంటే సమ్టైమ్స్ ఎక్కువ రావచ్చు, తక్కువ రావచ్చు. నెంబర్ టూ, దేర్ మే బీ ద ఫ్లక్చుయేషన్స్ ఇన్ ద లోడ్. ఇన్ బోత్ ద కేసెస్ వాట్ ఎవర్ ద ఫ్లక్చుయేషన్ ఈస్ దేర్, దట్ డజంట్ మ్యాటర్, that device should provide always a constant value of the voltage. Let us see in both the cases how the zener diode provides constant voltage. First, case number one, variation in input voltage. Let us suppose the input voltage which is coming into the home itself changing. Then how the stabilizer helps to provide a constant voltage? Let us see. Suppose load resistance RL remains constant and input voltage is changing. If the input voltage is changing, then how the zener diode provides constant value? Let us see, right? Case number one, if the input voltage is increasing, so more power is coming into the home, then what happens? Whatever the voltage is increasing, according to that, the current which is passing through the device increases. So the current I increases as the voltage increases. Total current I is equal to Iz plus IL na. So whatever the current I is increasing, according to that Iz increases, but IL remains constant. That means, so now input current I is increasing. Now I is equal to Iz plus IL. When I increases, now this diode what it will do? It keep load current IL remains same, but whatever the changes happens in I, that will be taken by the zener diode. That means now Iz increases. So as the increase in the input current I, that much current is increased in the zener current Iz, but IL remains constant. In this way, output current is constant, that means output voltage remains constant, right? Now let us suppose input voltage is decreasing. Now next case is, let us suppose input voltage is decreasing. Now what happens? Whatever the input voltage is decreasing, this diode reduce its current to that value. That means whatever the current is decreasing from the input, that much current is decreased in the diode current, but IL remains constant. So if I decreases, according to that value, the current which is passing through the diode decreases. Now what it will do? Before, if the current is more, the total excess current is taken by the diode. Okay. Now if the current is decreasing, then what happens? This time diode itself reduces its value, so that load always constant. So if it is more, it will take. If it is less, it will give. So in this way, diode current changes. IL remains constant. Zener diode provides constant voltage. Now next case, let us suppose output load is changing. That means there is a variation in output resistance RL. Okay, if the load resistance is changing but input voltage is constant, that means the voltage which is coming into our home is fixed, load is changing. Let us suppose if the load is changing, then how diode provide constant voltage? Let us see. For any changes in load, zener diode should provide a constant output voltage. Let us suppose if the load is increasing, if the load current is increasing, that means IL increasing. According to that, zener diode current decreases. That means input value is now fixed. So I is fixed. I is equal to IZ plus IL. Right? Now what is happening? IL is increasing. So zener diode will provide more current to the load. That means if IL increases, whatever the increase is happening in IL, that is decreased in IZ. In this way, if IL increases, IZ decreases. Right? Let us suppose if the load is decreasing. If the load is decreasing means load current is also decreases. If IL is decreasing but input is constant, so I is equal to IZ plus IL na. So now IL is decreasing. Then what happens? Zener diode current increases, right? So IZ increases if IL decreases. In this way, whatever is happening in the load, that is taken by the zener diode. In this way, output is always equal to the VZ. That means voltage drop across the zener diode. Summary. So finally, zener diode helps to stabilize the voltage. That's why it is used as a voltage stabilizer, voltage regulator. When zener diode is connected in reverse bias, if the voltage is greater than the zener breakdown, then reverse saturation current increases rapidly. Now the voltage drop across the diode is fixed. Now that voltage is called VZ, breakdown voltage. Now that voltage is constant, that is given to the load. Total current is divided into two parts, load current and zener current. I is equal to IZ plus IL. So these fluctuations may happen in input or output. If the input fluctuations are occurring, that means input voltage is changing. According to that changes, zener current IZ changes, keeping IL constant. Similarly, if the load variations are taking place, that means if output is changing, according to how the IL is changing, IZ modifies itself, so that always it provides a constant value of the voltage. This is how the zener diode acts as a voltage regulator. Thank you. Thank you very much. Please watch, share, like, comment my videos. Thank you.